Hello and welcome back. Today we're going to be looking at a kind of complicated, but not that complicated, present value of compound interest question. So we're just going to work this out quickly. I'm not going to waste too much time. Let's look at it right now. So let's look at our key values like always, or let's read the question first. So Mary invests $1,000 and wants there to be $2,000 in her account when she withdraws. How long should she let her money grow if it is compounded? Let's just put that in. If it is compounded 10% per year. Okay, so let's look at our key values. So she invests 1,000 and she wants to withdraw 2,000. And how long should she let her money in? So how long pretty much means number of compounding periods. So we can right off the bat write that we need to find n, and we have our principal is equal to 5,000, and we have our amount. Sorry, yeah, our amount. I was right. Never mind. Amount is equal to $2,000. And in this case, we know that we're working on a present value problem, right? So we can oh sorry, I put 5,000 here. My bad. Oh, my mistake. It's 1,000. Sorry about that. And then amount is 2,000. Okay, and so we know we're working on present value, right? So we can write PV is equal to 1,000 pretty much because present value. So and then when you look at I, it's 10% per year, so it's pretty much 10%. Get rid of the percent, which is 0.01, and now we can solve this problem pretty easily. So, like always, let's write down our formula. I'm just going to derive it. So, is equal to P1 plus I to the power of n. Divide, so it's P is equal to A over 1 plus I to the power of, sorry, handwriting got a little crooked there, didn't it? Let's go back to normal. A over 1 plus I to the power of n, right? So we can say P is equal to PV, right? I'm just gonna write that there. So it's essentially PV is equal to A to the power A over 1 plus I to the power of n. So now let's sub in our numbers and variables and everything and answer this question. So I'm gonna do it over here. So I'm just gonna draw an arrow sign showing that I'm working on it over here now, because I want these values up there as I plug them in. So present value is 1,000, and our amount is 2,000, and our interest is 0.01 to the power of n. Okay, so we don't know what n is right now. So how do we solve for n? Well, there's lots of ways to do this. First thing we can do is we can take this over here and multiply it by 1,000, right? So we'll get, okay, now I'm just going to scroll down and work on this. Okay, so I'm going to bring it back over here now. So what we have is 1,000, 1 plus 0.01 to the power of n is equal to 2,000. Okay, so what does that mean? It means 1 plus 0.01 to the power of n is equal to 2, because 2,000 divided by 1,000 is 2. And then now what we do in this case is first we have to simplify this inside, right? So 1.01 to the power of n is equal to 2. Okay, so in cases like this, what you do is you can use the log function now. So what you would do is you would write so you would essentially, this is what you would do. A lot of you already probably know this, but okay, I'm just gonna do it anyways. Sorry about that. Okay, so I'm just gonna write it down in a little pause there. Okay, so now what you do is you write log 2 over log 1.01, and essentially what this function will do is write this number, so this value, so that the n value is the same. So what value to the raise to the power of n will be equal to this, because if you equalize, it's pretty much writing this value is equal to this value, but this value, so that the n values of both of them are the same. So if you write it down, so if you do log, it's hard to explain with text. If I show you, it'll be easier. So if I do log 2 over log 1.01. Oh wait, did I do that wrong? Oh my bad, sorry. It's log 1.01. Hold on 1 second. I seem to have made a mistake. Okay, so now as we can see here, I've made a mistake and I've isolated that mistake and I know what it is now. And whatever, it seems like now I've shown you a counterexample of what not to do, and now I'm going to fix that. So here we have a counterexample and an example. Look at that, a blessing in disguise. Okay, so what the mistake was is if you'll go up here, see, this is why I'm not good at basic calculations. 10 divided by 100 is not 0.01, it is 0.1. So in all our calculations, what we should have had was 0.1, 0.1, 0.1, and essentially our last value should have been 1. Let's cross this out. It should have been 1.1 is equal to 2 to the power of n, sorry. And so when you log it now, what you're logging is log 2 over log 1.1, and if you solve this, you'll get your n value. So your n value will equal I think so let me just do it. So log 2 over log 1.1 is equal to 7.27 years. So this means that if she wants to have so you can write years. The reason I'm writing years is that you can write compounding periods, but in this case the compounding periods are per year, right? So compounding periods are equal to years. So you can just do that there if you want. For those of you that might not have known that. Okay, so now let's go back. Now we like always write a therefore statement. So therefore, she will need to let her money grow for essentially 7.27 years. Right? So that, as you can see, it's not hard. It's pretty simple. I mean, I did make a mistake, so I guess it's not that simple. But yeah, that's a kind of a thinking type problem for compound present value of a compound interest. All right, thank you for watching. As always, we'll see you back next time when we discuss another mathematics.